Question 6. An object starts from rest and accelerates uniformly for 3.0 seconds until it reaches a top speed v. It then travels at this constant speed for 5.0 seconds before decelerating uniformly to rest over the final 2.0 seconds. The total distance traveled during the entire motion is 75 meters. What is the value of the top speed v? To solve this problem, let us recall what we know about velocity time graphs of motion. Uniform acceleration from rest produces a straight rising line on the velocity time graph, forming a triangular area, and the area under this section represents the distance traveled during acceleration. Constant velocity motion appears as a horizontal section on the graph, and the distance traveled is velocity multiplied by time. The total distance traveled during the entire motion is therefore the sum of the areas under each section of the velocity time graph. Now let us analyze the motion step by step. First, consider stage 1, where the object accelerates from rest for 3.0 seconds. Since it starts from rest and reaches speed v, the acceleration is v divided by 3.0. The distance traveled during this stage is 1/2 multiplied by acceleration multiplied by time squared. Substituting the values gives distance in stage 1 equals 1/2 multiplied by v divided by 3 multiplied by 3 squared. This simplifies to distance in stage 1 equals 1.5 v. Next, consider stage 2, where the object moves at constant speed v for 5.0 seconds. The distance traveled in this stage is velocity multiplied by time. So distance in stage 2 equals 5.0 v. Now consider stage 3, where the object decelerates uniformly from speed v to rest over 2.0 seconds. For uniformly changing velocity, the distance traveled equals the average velocity multiplied by time. The average velocity is 1/2 multiplied by v plus 0. So the distance traveled is 1/2 multiplied by v multiplied by 2.0. This simplifies to distance in stage 3 equals v. The total distance covered is 75 meters. This is equal to the sum of the distances from all three stages. So 75 equals 1.5 v plus 5.0 v plus v. This gives 7.5 v. So 7.5 v equals 75. Solving for v equals 75 divided by 7.5. Therefore, v equals 10 meters per second. So the top speed reached by the object is 10 meters per second. This is our final answer. What did we do? First, we visualized the motion using a velocity time graph. Then we calculated the distance traveled in each stage using the area under the graph. Finally, we added the distances and used the total distance to solve for the unknown speed. Here is a quick recap of essential points. Draw the velocity time graph to clearly visualize the motion. Remember that the area under the graph represents the total distance traveled. Uniform acceleration from rest appears as a straight rising line. Constant speed appears as a horizontal line. Uniform deceleration appears as a straight falling line returning to zero velocity.